In this particular section, we're going to talk about how to multiply, divide radicals, how to rationalize them, so we'll learn what that even means, and also how to use a thing called the conjugate to rationalize fractions. So here we have several different statements, all involving radicals. There's no variables on here, but a lot of this looks very similar to some of the stuff we did earlier in the course. For example, let's focus on this very first one here. This is like a distributive property problem. We can go ahead and take this radical that's on the outside and multiply it into everything else. So you're going to get the third root of 2 times 4 is 8. Now the third root of 8 is 2, of course, plus, and then on the second multiplication problem, we get the third root of 24 because 12 times 2 is 24. Now, 24 splits into a perfect cube times 3, so 3 times 8. And we already said the third root of 8 is 2. So this would be the final answer. This is the best you can do. You cannot take 2 plus 2 and get 4 for the same reason you can't take 2 plus 2x and get 4x. This would just simply be where you're at after you simplify. So make sure you don't add 2 and 2. You just write 2 plus 2, third root of 3. Now in the second example down here, this is actually a FOIL question. It's a lot like 2 plus x and 4 plus x. And we can multiply those two things together using the FOIL pattern. So let's go ahead and do that. 2 times 2 is 8. On the outside, we get 2 radical 7. And on the inside, we get 12 radical 7. Then, for the last part here, we're going to get 3 times the square root of, now you've got to take 7 times 7, and you get 49. Now that is a perfect square, and of course anytime you take, like for example, square root of 7 times square root of 7, you're just going to get plain old 7. You don't even have to write 49, radical 49, you can just go right to 7 there. So this is 7 times 3. Over here we have 8 plus, these are like terms, 2 plus 12 is 14 radical 7. And then I want to point out that here at the end, this is 21. So we can combine that 21 with the 8, and our final answer would be 29. That's 21 plus 8, plus our irrational part, 14 radical 7. That would be the answer there. Let's take a look at this problem. This also is a FOIL question. If you recall, we did things like x plus 3, the quantity squared, and we got x squared plus, and then you had to do the outside and the inside. That was 3x and 3x. That makes 6x plus 9. So you always get a middle term when you square a binomial, and you'll always get a middle term when you square a radical binomial, for lack of a better term, like we have here. So we're going to take negative 2 times negative 2, that's 4. We could also square this. That would be 9 times 6, or 54. And then the middle term, remember, you're going to multiply those two things. That's positive 6, radical 6. And then you're going to have 2 of those, so plus 12 radical 6. Now we have some like terms. This 54 and this 4 can combine. So 58 plus 12 radical 6. Now on this screen, what I'd like you to do is to try these problems and pause the video, and then I'll flash up the answers here in a second. Okay, there's all the answers. So go ahead and pause the video and check your work on your paper, see how you did. Another concept that I need to show you is getting rid of a radical from a denominator, because that's considered unsimplified. If you're doing a multiple choice standardized test, for example, like the ACT, you'll never see 1 over radical 2 as an answer. They will do a thing called rationalize it. That is to say, get rid of the radical from the denominator. And the reason is because before computers, it was really difficult to divide by an irrational number. So it's better to get a nice integer or something on the bottom rather than an irrational number. So the trick is to multiply by the number 1, because that won't change anything if you multiply by the number 1, and we can't change the decimal value. This is roughly 0.8. So the trick is to multiply by the number 1, but really not number 1. We're going to multiply by something divided by itself. That's the same thing as 1. So we're going to multiply by the radical 2 over itself. That's the number 1. And when you multiply straight across, you get 1 radical 2, which is radical 2. And on the bottom, you get the square root of 4. So the final answer here, rationalized, would be radical 2 over 2. And I want to point out that that would also be 0.8. We haven't changed the decimal value. It's still 0.8. So that's really important to understand. Now on this next one here, we're going to multiply by radical 28 over radical 28. So we're going to get 12 radical 28 over 28. You don't have to actually go to your calculator and figure out what 28 times 28 is. Just know that the radical times the radical just makes the radicand as your denominator there, which is 28. Now, we can go ahead and do some simplifying on this. 12 goes into 28, and not 12 goes into 28, but they're both divisible by 4. So that leaves behind a 3 and a 7. So we have a 3 and a 7. Now, radical 28 actually has a square root of 4 in it. It is the square root of 4 times the square root of 7. So the final answer would be 6. That's 3 times the 2. The square root of 4 is 2. 6 radical 7 over 7. Now on this final question here, we're going to multiply by only the radical, which would be 5b, radical 5b, and that equals 5 radical 5ab, all over 3 times. Now remember, we don't have to write 25b squared. We can just write 5b with no radical. So these 5's here actually cancel, and we're left with radical 5ab all over 3b. That's the fully simplified form. So once again, go ahead and pause the video and give these two a try, and then I'll put the answers up. Okay, so there's the answers to those two. Check your work. Okay, finally, the last thing I'm going to cover is using the conjugate to clear radicals from the denominator. So in this example right here, don't write this down, but we can't just multiply by radical 5 over radical 5, because when we do that, we get 2 radical 5, and then we have to do the distributive property on the bottom, and we would get 3 radical 5 minus 5. So that didn't clear the radical, so we're going to have to try something else. And what you're going to do is use a thing called the conjugate of the denominator. And this is used in several different areas in math, not only with radicals, but we'll use it other times throughout the year in Algebra 2. We're going to multiply by a different thing. It's going to be 3 plus radical 5. So we're creating a sum and difference pattern. And you have to put the same thing on the top. 3 plus radical 5 has to go on the top also. So you have to multiply by the same thing. Instead of 3 minus, we change it to 3 plus. That's what the conjugate is. Now, on the top, you're going to get 6 plus 2 radical 5. Now, on the bottom, you have a sum and difference pattern, so you don't have to FOIL that out. All you have to do is take 3 times 3, that's 9, and then negative radical 5 times positive radical 5 is going to be negative radical 25, which is 5. You see, now there's no radical in the bottom. So our final answer would be 6 plus 2 radical 5 all over 4. And then you should always check there, the top is divisible by 2. If you factor a 2 out, it is divisible by 2, and so is the bottom. So you can factor that 2, leaving a 2 behind. So the real simplified answer would be 3 plus radical 5 all over 2. You can factor a GCF out. A lot of students get confused by this. I factored a GCF right there on the top, and then what happened was that GCF canceled with the bottom. That's important to understand. On this second one, I'm going to multiply by the conjugate, which will be 6 plus radical 2 and 6 plus radical 2. Notice those have to match, but the sign is different from this minus right there. So then, when I multiply it out, I FOIL out the top, I get, let me zoom in a little bit here, I get 18, and I'm going to get 6 radical 2 and 3 radical 2 makes 9 radical 2, and then radical 2 times radical 2 is plus 2, all over, now in the bottom I'm going to get 36 minus 2. So the final answer is going to be 20 plus 9 radical 2 all over 34. And I'm looking at those three numbers, 20, that's 5 times 4, or 5 times 2 times 2, 9, which is 3 times 3, and 34. And there is not a common factor, so there's nothing we can factor out of the top that cancels with the bottom. So that would be our final answer right there. And here's the final slide where you can try working with the conjugate on yourself, multiply by something over itself, and see what happens. I'll put the answers up in a moment. And there's the answers to the last few. So take a look and check your work. And good luck on the section.